Welcome to the sixth session, To Be or Not to Be, that is the question. For those interested in the compatibility of Christianity and science. And today's topic is God, physics, and mathematics. I just want to remind you very quickly and briefly, because after 6 sessions you know what the signposts are, but worldview determines what you see, and thus that perspective with which you perceive the world out there determines your values, your attitude, your behavior, and it shapes your belief system, and it defines probably your life philosophy as well. I think we must recognize that absolute truth is unequivocal. There is only one truth. And the other important aspect on the signposts is that nature and the laws of nature are prescriptive. They have always been existent and there. And what we do in science to get knowledge, we describe what we see, we experiment, we draw up a thesis which may become a law of nature if it is always true. If it can be falsified just once, it isn't. But man's efforts are descriptive and nature is prescriptive. In operational science, which I described in a way just now, there's also historical science and forensics. And the purpose of this series is really for you to explore some of the things we see out there in a much deeper way, explore it a little bit in depth, and have a look at what is worth knowing. Maybe the word mathematics already gave you some fear what this might be all about, but don't worry, it's not difficult. I will show it to you in a moment. Math is very easy. You know that even your dog can do it? A dog does it every single day. Look at this. The one says to the other canine, if my calculations are correct, our next feeding should be within the next 10 minutes. So it's not so complicated. This can look very confusing if you've never seen it before, but those things that are highlighted in color, you have probably seen before. So how useful is mathematics in describing nature? Well, I've taken the field of aerodynamics because it is my speciality from many years ago. I've probably forgotten a lot, but I just wanted to show you that bees know how to do it, birds know how to do it. We human beings try to imitate it on something like aircraft, and you see the Concorde up there, but aerodynamics is very important in many fields. Also the wind resistance of tall buildings and towers, and the shapes have a very big influence on the aerodynamics and the stress loads, wind loads on these buildings. You know, we've all maybe seen vortexes. Vortexes you can sometimes see on a humid day on the tips of an aircraft coming off there. You may have seen it as a passenger. But these vortexes are powerful. They are very, very powerful. There is a lot of energy in them. So if a smaller aircraft lands behind one of these big ones and gets into one of these vortexes, it can easily be destroyed. The aircraft, I mean, the one following. Here is just a schematic of how these vortexes develop. And these vortexes are actually a manifestation of the drag and lift that comes out of the wing. Now, birds actually make use of these things, like this owl in a wind tunnel that was flown through helium bubbles, and you can see the vortexes between its wings. The birds make good use of it when they fly in formation, because the leader has a vortex coming off every wingtip, and the goose, they fly behind it in such a way that the upcoming airstream from the vortex gives them extra lift. So birds do it. They know how to do it. In motorcar racing, especially Formula One, look at all the aerodynamic surfaces they put on the nose of these cars, all the studies they do in wind tunnels. It's very complex. It's very experimental. But there's also a lot of mathematics involved here. We're not going to go there, aren't you glad? But there's another area of mathematics in the physics. You know, when a raindrop comes off your umbrella that is wet, that is similar or analogous to when you want to launch a rocket to the moon. You have to launch it at the right moment, because in Florida, more or less, at the latitude of Cape Canaveral, where these rockets are launched, the Earth is running at about 1,000 kilometers an hour in the tangential speed, like rotating your umbrella. And then you have to hit the moon, not literally, but figuratively. You've got to hit the moon 3 or 4 days later. That is also moving at a massive speed. The Earth itself and the moon as a system is very dynamic. The Earth is running at about 30 kilometers a second around the sun. All this has to be calculated to make sure that the moon landing can in fact take place. When it comes to Mars and other planets, it gets even more difficult. And I just wanted to remind you again that the Earth is moving at 30 kilometers a second around the sun. The sun and all its solar system, all the planets around it, are moving along at 230 kilometers a second, not per hour, a second. And to hit the right spot needs a lot of maths. There's a lot of maths also in prediction of hurricanes and the weather that's not always visible to us. It has become very accurate. But all these different color lines here are different models on how to predict the path a hurricane will take. And of course, you can see that it is bunching up a little bit, but the longer or the further downstream in time, the more uncertain it will be where this hurricane is going. And of course, electromagnetism and radio and cell phones and all that stuff is very complex in its mathematics, but that makes the cell phone possible. You have to understand those principles for electric motors, for lights, for amplifiers, for guitars, whatever you want that works electrically. It is complex, and that's where the mathematics also gets quite complex. If you consider an ordinary thing, like a rainbow, it's not as ordinary as what one would think, because the mathematics inside these little droplets that are in the cloud and in the sky there, and the light coming in at a particular angle, is a lot of mathematics. Now, why would our mathematics be able to predict a rainbow? If we look at the mathematics of a honeycomb and the bee, it is amazing that this little critter thing called a bee can work out the mathematics, which is the most optimized way of having regions of equal area with the least total perimeter. And it builds these honeycombs without thinking, I would say. Okay? So there's mathematics in that as well. Here's something you might remember from school. You have a brick or a weight or a piece of wood that is sliding down a slope, and you try and work out what force would stop it. Okay, and there it is. F is mu times n. We won't go into it. But if you go into it a little bit more in the general sense, then it looks like this. And it can get a little bit more complicated. Not complex, complicated. If you have a ladder that has friction on the wall and friction on the floor, and it might be different, and then it depends how heavy the person is climbing this ladder. So you can work out all these things. It looks rather complicated if maths isn't your thing, but this is only maybe school level or first year university. The motion of projectiles and many other things can be calculated, at least theoretically, very accurately. But these parabola, these shapes that the projectile flies on, become more complex if you also have to add in wind and the rotation of the earth and different densities of the air levels, because air gets hotter and colder in the different levels. So the projectile has to fly through all that, may it be a stone or a gun projectile or whatever it might be. So there's a lot of maths involved. And I can tell you, if you approach mathematics slowly, diligently, and you develop a taste for it, or maybe even passion for it, by doing what? Changing your attitude, then anyone can do mathematics, even advanced mathematics. And the proof is me. I had an F in mathematics in my university entrance matric. I rewrote and I got an E, and I thought that means enough. So I obviously didn't have much of a clue in maths, and yet I decided to do electrical engineering and later switched to, as a second qualification, I went to aeronautical engineering, and I focused on a subject matter, aerodynamics, which is highly, highly, highly mathematical. And I enjoyed it, and I passed it, so it can be done by anyone. Why the Matterhorn in the background? Well, it always looks like a very, very high peak. But you know, anyone, even somebody with an E or an F in maths, can actually get there if you look at the top occasionally and then you focus on your feet so that you don't slip and you do your thing. And that brings me to what some real-world mathematicians said. It is ascribed to Albert Einstein that he said the eternal mystery of the world is that we can understand it. Think about it. That is a mystery. The world out there, the real world, the physics world, we can understand it. And how do we understand it? We understand it through mathematics. And mathematics provides a wonderful harmony between the given, the prescriptive, as I call it, on the one hand, and the reason on the other. But the reason, the human mind, is descriptive. And Hermann Weyl was a very, very famous mathematician in his day. Max Planck, a theoretical physicist from Germany, said it is not at all obvious that the laws of our thoughts, in other words, our mind, which is non-material, remember, coincide with the regularity of the flow of impressions which we receive from the external world, the real world. What he says is, how can our thoughts be completely compatible with what we see out there, the mathematics and the natural world? How does that go together? The external world represents something that is totally independent of us, but there is something absolute which we confront here. And I think you've got to be a little bit, you must have a bit of background in mathematics to really appreciate that. But the enormous usefulness of mathematics in the natural sciences is something bordering on the mysterious. And there is no humanist rational explanation for this. It is also not at all natural that the laws of nature exist. Yet Newton's law of gravity, which was articulated mathematically by Isaac Newton, have proved accurate beyond all reasonable expectations. So it is really difficult to avoid the impression that we are facing something that is very, very mysterious. And these three sayings are ascribed to Eugene Wigner, a physics Nobel Prize winner. So where does that leave us? Well, you don't have to be a mathematician, but you have to be smart. And Leonardo da Vinci, one of my heroes actually, amongst other things, he was a real polymath, was mathematician. And he didn't use all these symbols. He used something relatively simple, like the golden ratio. It fascinated him that there is such a thing as the golden ratio. And I will explain to you in a moment. Pythagoras, which we met already with the right angled triangle, you remember? R squared is A squared plus B squared. He hypothesized that the most basic constituent of the universe wasn't some material substance or even the energy in it, but rather numbers. And that is very long ago that Pythagoras said something like that, okay? Leonardo couldn't agree more. Leonardo was able to translate motion and other principles of physics, like light and perspective, by observation into drawings and paintings. But he noticed a couple of things. A lifelong preoccupation with geometric shapes and patterns and the incorporation of light and perspective and emotion in mathematics found its way into all his sketches. And you will see just now where the mathematics comes into this. Here are drawings of him. I mean, I couldn't even draw this with a ruler, never mind without it. And he does it in 3D, okay? And he notices something. He notices that if you have this pentagon in there, that if you look at the ratios inscribed in a circle, and he discovered that this ratio, he called it phi because it makes an angle, but the ratio is 1,618. 1,618. Now you say, okay, so what? Where does that come in? I'll show you where it comes in. It is in his most famous drawing, a painting, because he paints according to that ratio. And the ratio has a very, if you depict it in a different way, it looks like a spiral, okay? And this is how it came about, this Fibonacci series, as it is called, the Fibonacci series and the golden ratio. You take a number line and you take a 1, plus 0 is another 1. Then 1 plus 1 is 2, 2 plus 1 is 3, and 3 plus 2 is 5, and 5 plus 3 is 8, and so it goes on. You always add the previous number to the current number, and you get a new number. If that's too complicated, don't worry about the details now. But the Fibonacci series, if you now divide the two numbers, the later one, and you divide it by the previous one, then you get this ratio, 1,6, 1,63, 1,615, etc. And already after about 12 iterations, you have arrived at 1,618, and that's where it stays. It becomes just more precise in terms of 1,618. And this is what it looks like in the form of squares and spirals. So if you depict it like that, this is what you can do with it. You discover it everywhere in nature, everywhere. You can see it in this sunflower. If you've never been aware of it before, look at these spirals inside here. And if you look at them very closely and you look at the mathematics, then you see a Fibonacci series. Now, why would a sunflower have in its structure the Fibonacci series? Why? There's no reason for it to be there. But now check out cauliflower, broccoli, pine cones. The pine cone at the top there has always spirals in it that are the exact values of the Fibonacci series. This plant in the middle, I don't know what it is, but you can see it's got 1 and 2 and 3 and 4 and the fifth one there, and 5. It's got 5 of these spirals, and 5 is a Fibonacci series. You see it in cabbage that you cut in half. You see it at the bottom left there in the mixture of I think it's a mix of a cauliflower and a broccoli. And you see these wonderful patterns, and they're all according to the Fibonacci series, and ferns, and the kiwi fruit, and this flower there. But here's an amazing thing. This Fibonacci series, you see it in plants, you see it in animals. Look at this shell that has been cut in half. This little critter that lived in there built another chamber every time it needed more space, and the ratio A plus B over A always becomes the Fibonacci series. Now, why would a little critter that lives inside that thing know that? And why would the Fibonacci series be found all over nature? It's almost like a fingerprint. A fingerprint of what? It's a very subtle hint that there is some, I would almost say, mysterious combination here. And the mathematics lights it up. And you find it everywhere, as I said. You find it in dry riverbeds. You see it in the fern as it develops. You see it in a tree, in the branches. You see it in the blood vessels in your kidney. You would see it in a delta of a river. It's just amazing. And human beings have recognized that Fibonacci series and put it in the head, I don't know what you would call that, of a violin and some of these instruments. You will see it the next time you go to Pick n Pay, now that you know about it, because the Fibonacci numbers can be found in pineapples and bananas, amongst other fruit. Bananas have 3 or 5 flat sides. Have you ever noticed that? Bananas have 3 or 5 flat sides. Pineapple scales have Fibonacci spirals in sets of 8, 13, and 21. Look at this. You throw your wet hair backwards, like this lady does, at the sea, and if you plot that, you get the spiral which underlying it has the Fibonacci series. There are these squares arranged in that way. Okay? You see it in a hurricane. You see it in a shell like this. Again, where does this little living thing that lives inside that shell get the brains to build this? Mathematically precise every time. How does this bird get it right to have these eyes in the tail in the form of spirals that form an exact Fibonacci series? You even find it in music. Now, I'm not very musical, but if you take the keys, the black keys, you get 2 together, and in between you got white keys. Then you have 3 keys. 2 plus 3 is 5, right? So we have 5 black keys. We have 8 white keys. And here on the right side, I'm just depicting the Fibonacci series again. 1, 1, 2, 3, 5, 8, 13, etc. And this is what we're getting. 13 keys in an octave. The numbers are all there. 2 to 3 to 5 to 8 to 13. Galaxies. Look, they look very much like they are also incorporating Fibonacci series. The Parthenon was built on purpose to reflect the golden ratio, as it was called. The Mona Lisa, your forearm, the hand to the... Now that one is a little bit of a tricky one because not every person will have that exact dimension 1,618, but it will be close. It will be close. And even the pyramids are incorporating the Fibonacci series and a human face. All I'm saying is, with this very simple example of the Fibonacci series and some of the other things we looked at, is mathematics is almost everywhere. So the question now arises, what can we learn just by looking at these few examples of mathematics and the natural world? I want you to think about this. The fractals, the Fibonacci series, the universe, Leonardo da Vinci and his golden ratio, the transcendental numbers E and pi only means something for somebody who knows a little bit more about the maths, but the fact that there are such numbers is amazing. The compatibility of mathematics and the natural world is a wonder. It's a wonder. How would that be? The one is in the mind, the other one is in reality hard physics. It is often assumed that the ancient world was without mathematics and that they had little understanding. Yet Egyptian culture, if you just look at the pyramids, for example, Roman culture, for example, and Leonardo da Vinci, they knew more of maths than what we give them credit for. It's not that they knew about integrals and calculus and stuff like that, but they were able to figure out mathematically in their minds what they had to build and how to build it. Finite element analysis or computational fluid dynamics has enabled engineering and the operational sciences to calculate to many orders of magnitude of precision, incredible precision. An example is the Boeing 777 that was built virtually only on the computer, and through computer-aided design and computer-aided machining, it was put together. And I remember the words when it flew for the first time. The engineer said it flew exactly as predicted. Now, how can they say that? The mathematics that forespelled the behavior of this aircraft in terms of the structure, the aerodynamics, the flight dynamics, all these things, was exactly like the computer said it would be. For that, the mathematics has got to be perfect. Or even going to Pluto. With all the dynamics in the solar system, you want to hit that speck that is so far away that it took 15 years to get there. It's amazing that they flew past it at a very incredible speed. I think it was 50,000 again, miles per hour, kilometers an hour. I'm not sure. It doesn't matter. It's very, very fast. And it took photographs. That's all mathematically based. Mathematics. The miracle of mathematics is that maths and nature speak an identical language, yet the one is a perfect match on the natural laws of physics, the reality out there, and the other is a construct of the human mind. The one is material, the other one is non-material. How does that fit? How does that work? Einstein was a real genius. He combined for the first time the aspect of time and mass and energy when he formulated that very basic but profound equation E is mc squared. And his Einsteinian gravity field equation combines how space-time curves and how matter and energy is distributed in the universe. And he found an equation to put these things into harmony. And that's really the beginning of relativity here. Again, we're not going to go there. I just want to show you how powerful this is, because Einstein did this in the 20s and 30s, 1920s, 1930s, and many of these things are only proven experimentally now. Our brain doesn't contain real physical objects out there, like a physical triangle or a dog or even numbers or mathematical algebraic equations. They don't sit there on a string. There are no copies of real machinery in the head, yet the mind entertains abstract ideas or models that don't correspond to anything that is there yet, like designing a Boeing 777. But it can juggle those concepts in its non-material mind with incredible power, ingenuity, and precision when applied correctly. You can also be very precise and totally wrong. Now, these constructs of the mind can be developed into a tangible physical artifact, such as the internet or nuclear power stations, or be used to conduct research in volcanology or genetics or insect flight or ice ages or anything. The mind can conceive smartphones and roller coasters, new recipes to be used in the kitchen, 5G communication and artificial intelligence, and space probes flying to Pluto and beyond. And to a large extent, that is based and enabled by mathematics. So I've done a long recourse now on that we have mathematics everywhere, but how amazing it is that mathematics and the physics out there actually speaks one language. Could it be that there is one author? And I mean, I'm wearing my t-shirt today in honor of this, the most beautiful equation. It is even called that on the internet, but I really feel that it is. It uses two transcendental numbers, e and pi, and an imaginary number, I, and a 0 and a 1, which are really the most basic things, and puts it into a profound equation that is used in engineering in many places. And Einstein, as I said already, by combining energy and mass and the speed of light, combined time and mass and energy. That's genius level. But it comes out of a mind. It doesn't come out of material. It does not come out of the ink that provides the story for a book. So is mathematics man's invention or God's invention? Did mankind invent mathematics or discover mathematics? That's an important question, because it will depend a lot on your worldview. The way it describes all the natural phenomena, you would say it is prescriptive. Because just like nature, just like physics, like the laws of nature, the mathematics, when correctly applied, is always true. Why is it always true? Because it mirrors the physics exactly. Not roughly, exactly. But God combines all this mathematics and physics with information that we discovered in the, was it the previous talk or the one before that? And love. And if you now think about it, information and love and mass and energy and time, they all hang together. And it is just something to think about. It is profound, profound, profound. Even if you don't understand the deeper thing of mathematics, just the fact that it works, that almost everything in terms of gadgetry around you, in the house, in the streets, everything depends on mathematics describing the reality of physics. And there's lots of information and knowledge to be had there. Natural laws like physics can be described perfectly with mathematics. I said it a few times. Since the digital computer, however, the precision with which we can do that has increased million times, maybe billion times or trillion times. It's amazing. The worldview that birthed mathematics, by the way, was a belief of order in the universe, ordained by the Christian creator God and as articulated in the Bible. Now, in that little bullet point, there is a lot of information because the famous Western scientists were almost all of them had a worldview of a Christian God based on the Word of God, the Bible. And that in itself is amazing because the Western world really used mathematics to do science. However, many contemporary scientists and mathematicians tend to think still that mathematics is man-made, and that put order into a chaotic universe. You hear the difference here. The Christian tried to explain on the basis of the order they observed in the universe to express that mathematically, while man-made mathematics says, no, we put order into a chaotic universe. That's not true. The change in emphasis from Christian perspective over the last 150 years to humanism has very serious ramifications. The rise of almost all philosophies today, especially today, are hostile to natural theology, although a biblical perspective made the discovery possible. A probable consequence will be a loss of awe, a loss of perspective, a loss of hope in the future. In a way, those mathematicians, those humanists or atheists, are actually cutting off the branch on which they are sitting for a couple of 100 years already. So mathematics is either seen as a sign of human autonomy or as a biblical revelation of an all-powerful, infinite, sovereign God who left his fingerprint, in my words now, in the form of mathematics everywhere. So you might say, okay, why invoke God in this? Why the Christian God? A natural law is a given. If you look at nature, macro nature in the universe or so, or micro, if you go into the detailed workings of your own cells, there is no excuse actually for anyone to ignore that. The fingerprint of God, as I called it, is everywhere, in the physical, in the mind, in the spirit. Remember, when I use the word spirit there, remember you are body, mind and soul. And you do get people who say, no, I don't have a soul. Well, that is very sad, but you do have one. You've maybe just not discovered it yet, you know. You have a kidney too. Maybe you haven't discovered it yet. Over the last 6 weeks, we looked at biology, geology, cosmology, and information. And now we looked a little bit, a tiny little bit, at the queen of sciences, and that is mathematics. Now, for a guy who had an F in maths in matric, that's quite a statement to make. And I'm not the first one or the only one, and I'm quoting others here when I say Queen of Science. But I can see it now. I can see it. Just I see also the Creator God is real and what He has done through Jesus Christ, etc. We're going to get there still. We saw at least some life miracles, real life miracles in these talks. In each talk I had something, because we can explain them. Also mathematically, remember? Or otherwise, because it is rational and reasonable to believe what we see, what we discover, and beyond what we can actually imagine in our minds. We can make it. That's a real life miracle to me. Remember that the bigger system includes spirituality, because under information, remember, we discovered that God the Creator must be spirit, and that we are made in His image. So we also have an element of the Spirit in us. But of course, it does depend somewhat on what you're willing to see. It depends on your worldview. What do we need to internalize all this? Well, the thing that I mentioned a few times from day one, we need systems thinking. What does that actually mean? We must be more aware, consciously aware, that there is a bigger system out here. There's a bigger world out there. We living in the details down here, and we get confused because there are so many details, and we use our cell phones and haven't got a clue what's all going on behind the scenes, or we use the GPS, or we watch DSTV or Netflix or whatever. There is so much that's going on. Do you have to be an expert on all this? No, you can't be. I can't be. You know, I've even forgotten where I was an expert in, and that is aerodynamics. I've forgotten many of the mathematical tools that I used very easily in my days. But the natural laws and their consistency at micro level, atomic particles and quantum physics even, as well as the macro level when we get to galaxies and the stars and the outer space generally, and all levels in between, as I call it. Planet Earth is our habitat, for that matter also. There's so much to see in terms of the bigger system. Consider now the DNA that I introduced you to as the information carrier to build biological systems, not just human beings, every biological system. Even that little critter that knows the golden rule and builds its spiral home. Study Noah's flood effect on the Earth's geology. Don't get confused by the conventional wisdom that this is all millions of years old. It may be, but the evidence on the ground, in the ground, indicates it was much, much faster. There was no uniformitarianism, there was more catastrophic tectonics. And that tectonics was more vertical than horizontal. Long story, but if you study up on Noah's flood, from a scientific point of view, you will discover many things that you would not believe because you've been subject to a lot of movies and a lot of stories that are virtually lies. Now, why would people do that? Worldview, perspective, paradigm. Investigate further if you're that way inclined. The more than 120 fine-tuned constants that make life possible on this planet. All coincidence? My goodness, you believe that? Genesis 1 to 11, not verse 1 to 11, chapter 1 to 11, is foundational and profound. And I tell you what, that is why it is attacked scientifically over and over and over. But just read it with an open mind and have a look from different perspectives. Cosmology, origin of life, and even making you and me. Absolutely see the bigger picture, which includes God's Spirit and His Word. It includes the Bible, like it or not. You might not believe in it, you might not like it, but do yourself a favor. Just start reading some of it. This Bible is God's message, but written in man's ink. But the ink didn't write it. There was a human mind behind it that was guided through the Spirit by God. Ask God to guide and assist you. I mean, I can't guide and assist you. I'm not God. But ask Him. You ask, He will do it. I promise you. That's how it worked with me. But that's another long story. Now, Jesus is also real. He's historical, you know. And what is written down, there were many, many eyewitnesses. And also in what He said about Himself. I once had some 3 students coming to me. They were Muslim students. I could see it by their dress. And they said to me, straightforward, "Are you a Christian?" I said, "Yes." "Are you a believing Christian?" I said, "Yes." He said, "Well, we also believe that Jesus was a prophet." I said, "Okay, that's great. So what do you do with this one sentence that He said, 'I am the way and the truth and the life, and no one comes to God except through me'? What do you do with that sentence?" Oh, they disappeared. One of them sent me an email, and he said, "It really shattered me what you said to me." Anyway, that's another story. So start, if you want to read anything in the Bible, start with John's Gospel, just to see what it's about. Then go maybe to Romans, and then go to Genesis. You will get clarity, and you got at least something to start with. That's part of exploring deeper. It's not just the physics and the biology and the geology. That's all very material-like. But focus and study the detail as if your life depends on it, because it does. Determine what is the truth. Make your decision honestly and authentically. That's all I'm asking. I'm not here to convert you. That's God's role. But you must do the studying. You must be prepared to study. Or do you want to be able to say you learned how to read and write, but you never read? Then in my eyes, you're illiterate, because there is so much to learn. So why does mathematics work? And that is really the last point for me. Nature is very conversant with the rules of mathematics. I've just shown you a tiny, tiny, tiny little aspect of that. But both are prescriptive. That is amazing. Because nature is prescriptive and the mathematics fits exactly 1-on-1. Then mathematics must be prescriptive too. But the way we use it as a tool now, this descriptiveness, we've only learned much later. So mathematical thought and empirical reality seem to be mysteriously coherent. And the created world bears with it also a quasi-linguistic character, if I can put it like that. It is as if mathematical thought and empirical reality talk the same language. At least at this level, it sounds like God's world and God's word are coming together. The great truths mathematics deals with enables us to understand the concept of the absolute and the infinite. That is an amazing thought. And the common factor seems to be a creator God. He reveals himself in nature, in the Bible, in Jesus, and now you can even see in mathematics. Creation is thus a showcase of, I would say, this creator's splendor and wisdom and power. God is all things. So he must be a mathematician too, you know that? And he sustains everything in nature. Everything. So my last word is, like I started off 6 weeks ago. There are only 2 shows in town. You're either created or you're not created. Then you're just a random accident. Be the real thing. Don't be a screensaver. But that is your choice. And if you have further questions about that, then send me an email to exploredeeper@gmail.com. Explore without the E. So it's XPLORE deeper in one word. exploredeeper@gmail.com. If you require assistance in making this decision, are you created or are you not created? And you want to maybe know more. Okay. And on a lighter note, because we were talking about Leonardo da Vinci, here is a picture of the less famous Beano Lisa, which is not ascribed to Leonardo, because it obviously does not follow the rules of the golden ratio. This is the real thing. And the real thing is the truth, and what a difference it makes, right? So thank you very, very much once again for going through all these talks of mine, and the research behind it really was exciting for me. I mean, I've been studying this biology aspect, geology, cosmology, information, and mathematics because of my background for many, many years. And I've read on either side of the divide. And each one must decide for themselves. But I can tell you something. God is for real. He's left his fingerprints everywhere. So if you just look up, you'll see it. If you look down, you'll see it. If you look inside your body, you see it. It is just there. It is really foolishness to discount a creator, because he gives love as well and hope. But anyway, thank you very much once again. Continue exploring and have fun while you're doing it. Have fun. Try some maths. Thank you.